Everyone, let's discuss about the 8051 timers in this session. We know the 8051 architecture is having two timers, that is timer 0 and timer 1, which are 16-bit registers, right? Whereas the 8051 architecture do supports 8-bit information. Therefore, these two registers what we are using, they are 16-bit each. So we want this 16-bit register into separated or into be divided into two sections which are used to carry the lower byte of information and higher byte of information. So this 0 says that we are using timer 0 and L says that lower byte and H says that it is higher byte. So total 16-bit what we are using, it will be divided into lower 8-bit and higher 8-bit. So these registers what we are using timer 0 or timer 1. So even they can be used to store or to copy the information or to read the information like any other registers. For example, just look at this instruction. So this instruction is saying like you are trying to move the immediate value for F into the lower byte of timer 0. Right. So now we are trying to move the information into timer 0 of lower byte. Similarly, if you take out this example, you can see here the information which is present in the higher byte of timer 0 is loaded into R5. Therefore, these registers even can be used to store or to read the value like any other register. Similarly, we have timer 1 register, which is also a 16-bit register. This is also classified into two sections. That is TL1 and other one is TH1. So one says it is in timer 1 mode. So this is to store lower 8-bit and this is to store higher 8-bit of information. So you can see here. So this is we have taken for timer 0 lower byte and this is timer 0 higher byte. Similarly, we have the same classification for TH1, that is a timer 1 as TH1 and TL1. So this is to store the lower bit and this is to store your higher byte of information. Both the registers what we have discussed now, timer 0 and timer 1, they will use a register that is timer mode register. We name it as, or we call it as TMOD. So this TMOD is a 8-bit register where that 8-bit is divided into two sections, lower and higher. So this lower part of TMOD is given for timer 0 and higher mode or higher section of your TMOD is given for timer 1. So lower 4 bits is dedicated for timer 0 and higher 4 bits are dedicated for timer 1. In these 4 bits again the lower 2 bits what we have, it will be used to say about the mode of timer and the remaining 2 is used to specify the function, nothing but operation. You can see here just now I said, so TMOD is a 8-bit register. In that the lower 4 bit are for timer 0 and the higher 4 bit are for timer 1. In this the first 2 bits what we have, this is to say about the mode of your timer and the next 2 bit is to say about the set of operation we are trying to perform. So now first one we have the, you can see the other two functions what we said, gate and C bar T. So first we will take with gate bit. So this gate bit is nothing but the hardware way of starting and stopping the timer by an external source which is achieved by making gate is equal to 1. If you are giving gate is equal to 1 in the TMOD register, so this is the hardware way of starting and stopping the timer by an external source. So next we will go with C bar T, nothing but your clock or timer. So this is to decide whether the timer is used as a delay generator or an event counter. If this bit is equal to 0, then it is used as a timer for time delay generation, whereas the clock source for this time delay is the crystal frequency of the 8051. Therefore, the frequency for the timer is always 1 by 12th of the frequency of the crystal attached to the 8051. So now you can see here. So these two bits are to say about your mode, these two are to say about the operation. So this is nothing but, the gate is nothing but the hardware way of starting and stopping the timer. This is to check out whether we are using it as a timer or nothing but an event counter. So based on the value, that is c/t is equal to 0, then it will be used as a timer for time delay generation, whereas the clock source for this will be the crystal frequency of the 8051, which will be always the 1/12 of the crystal frequency. Right. So next you can see we have M1 and M0, nothing but mode 1 bit and mode 0 bit. So already we said we have three modes, that is mode 0, mode 1 and mode 2, and we will concentrate generally whatever you have three modes 0, 1, 2. So here you can see here. So first mode, that is mode 0, it is a 13 bit timer mode. Next we have 0, 1, that is mode 1, which is a 16 bit timer, and next we have 1, 0, that is mode 2, that is for 8 bit timer. So here we can calculate the values of the TMOD to operate as timers. For example, if you want to make it as mode 1 of timer 1. So if you want to calculate the values of a TMOD to operate as a timer, so for example, if you are taking mode 1 timer 1, then just look at the timer 1 section, make it as mode 1, nothing but 0, 1. So mode 1 is nothing but 0, 1. So the value for this will be 0, 0, 0, 1, that is timer 1, and timer 0 will be 0. Therefore, the value for this mode 1 timer 1 will be 0, 0, 0, 1, 0, 0, 0, 0. For example, if you want to find the value in mode 2 of timer 0, mode 2 of timer 0 if you take out. So this is your timer 0 section. If you want to make it as mode 2, then it will be the value of 1, 0. So now the overall value will be 0, 0, 1, 0, which is for timer 0, and the higher value will be 1, timer 1. Similarly, if you make it as mode 0 of timer 1, mode 0 of timer 1 means this is timer 1 section. So mode 0 means both the bits will be 0, 0, then 0, 0, 0, 0, that is timer 1, and of course the lower bit will also be 0. Right, this is how you can find out the values of TMOD to operate as timers. So just now we said that the clock source for the timer is nothing but the crystal frequency what we have of your 8051, which will be always the 1/12 of the frequency of the crystal attached to the 8051. So this is the example where we are trying to find out the timer's clock frequency and its period for various 8051 based system. So for example, if you take out the first one, that is 12 megahertz, so it can be calculated as 1/12 of crystal frequency, which is equal to 1 megahertz, whereas period is 1 by f, that is t is equal to 1 by f, which is 1 microsecond. Similarly, we have for 16 megahertz, that is 1/12 of 16 megahertz, which is equal to 1.33, whereas the period is equal to 1 by 1.33, which is equal to 7.75 microsecond, which is equal to 0.75 microsecond. Similarly, we have for the next case 11.0592, which is equal to 921.6 kilohertz, and again you have found out the period. So already we said, so the 8051 timers use 1/12 of XTL, that is your crystal frequency, regardless of their machine cycle time. So here the XTAL what we have, which will be generally 11.0592 megahertz. 11.0592 megahertz.